I want to welcome you to this training. We are winding up the training. So um, today we are going to be looking at quantitative analysis. So because I'm going to share my screen now.
All right.
So this is part of an aspect of what we've been looking so far. Yesterday we looked at qualitative data sets, and today we are going to be looking at analysis for quantitative. So today a very crucial and essential component of the training. Because most times the data sets we are going to come in contact with are usually most often uh, uh, are usually uh, quantitative data. So it's very essential that you know how to navigate this this particular type of data set. So I'll share my screen now. So I'm going to share my screen, and I'll pull up the data that we are working on. Just give me, sorry, stop sharing. Just give me a minute. Let me close up what I was doing. So yeah, I'm back now. So I want to pull up the data set we are going to be using. So this the data set we are going to be using for quantitative. Okay, so that's the data set we are going to be using. So this data set is basically we are looking at this fasting blood sugar. This is 2 hours postprandial. This is HbA1c. Then we have the gender here. Then we have the age. Then here we have the case classification. Then we have the age group here. Now the reason why we have these two here, another thing we are going to do now, I'm going to recode the gender so that we also have it as part of this. So you can see here we have two groups here, DM and non-DM. Then why for the age group we have quite number up to 5 groups here. So we have up to 5 groups. So here we are going to recode this gender now. So transform, recode into different variable, and then move the gender into what we want to recode now. Then we have gender that's recorded, the gender of the participants. So code and name. Then our name is coded as 1. We add, and the F is coded as 2. As 2. Add. So we say okay. And we continue. So you can see that we have it here. So what we'll do now is to go back to variable view. Then we have to go and give it label. Say 1 was male. Then say 2 female. So having done this, then what we want to do here, there are several analyses we are going to be running here. We are going to run uh, regression here. We are going to run correlation here. We're going to run t-test. Then we are going to run ANOVA. So now, we'll start with t-test. Now the t-test is, that we say for you to run t-test, you have to be comparing mean of what, or 2 groups. So this is 2 groups. This is also 2 groups. So you can actually run t-test for the mean value of each of these parameters between DM and no DM, or between male and female. So if you want to do that, you go to analyze, then you go to compare mean, then you click on one sample independent t-test. So click on that. Now remove your all these parameter. Now there's something that we have to change here. Let's go back to variables. You can see that this is number 2. This should also be scale. Then age is scale, so every other thing is correct. So this have to be to scale too. So we'll go back again, analyze, compare mean, and go to independent t-test, and you move. Let's say these are the 3 parameters I want to run mean on. Then we move this group. Now, let's say we want to run for this was. Then you have to come and define what you have. Remember, we have 1, then we have 2. So if you don't get the numbers that you use to code them, and you just put any number here, you will not have any result. So you click on continuous, Then you come here under options. Then you now just check what you want to. You don't need any other thing. Then you okay. Then you click on okay. So once you click on okay, your result will be out. So you can see. Now the first table is the summary table. So you can see the fasting blood sugar, RDN and not DN. Each of them is 10. And this is the glucose level of fasting blood sugar of those 10. And this is for this. And for 2 hours too, this is for this. No, these are just arbitrary data. So for HbA1c, we have 25, then we have 4.0. And this is the standard deviation, and this is the standard error. Now, the next table is actually where what we are interested in. Now, here, look here, we are saying that we have two outputs here. The first one is when you see equal variance are assumed, then equal variance not assumed. So the one, since we are not assuming equal variance, then meaning that our the statistic we are going to pick is going to be this second aspect. So now this is the T student test. You can see it here. This is 10.086 or 10.09. Then the degree of freedom, this is the degree of freedom, but we are not interested in that. Then this is the what's it called? This is actually the p-value. So the two most important value here is actually the t-test and the student's the significant two-tail, which is the p-value. So you can see this is 0.00. So if you want to write it, you just say less than 0.001. So what we are saying is that the p-value is less than 0.001. So, and it's also less than 0.05. So it shows that there is a statistical significant mean difference between the mean value of fasting blood sugar of DN patients against those that are not DN. So merely even looking at the arbitrary value here, you can see the actual value here. So you can see that it's not statistically significant. Then the next one is the 2-hour postprandial. You see that because it's the same value, you also end up having the same output. While the HbA1c2, you can see this is the value, then it's also statistically significant. But in this case, it's 0.02. So you round this one to this. Then while the t test is actually 2.83 3. So another thing we can also do is to also run the same test. In this case now, we are moving this place classification, then we are using age group classification. So you also have to come and define and tell, since it's still 1 and 2, then we'll leave it that way. Then every other thing still remain the same. Then we move in, then you go on, and we're going to have the value. Now, this is the output. So you can see the number. We have 11 male, then we have 9 females. So the mean value for male was this, while the mean value for female was this. Then the same thing here, the same thing here, the same thing here, the same thing here. So looking at this, you cannot come here and check if there was significant difference. You can see here there was no significant difference. This is 0.48, which is greater than 0.05. So it therefore means that the glucose level here is actually not, but you cannot really make a very good concrete inference here because we are looking at both DM and not DM. So if you want to now check stratify male and female, you have to go and first and foremost select. You have to go and tell the software to group this out based on. Now, how do we do this? You can come here under your data and actually tell your software to split your data. And in this case, we are going to tell to compare view, or in this case, we are going to tell the software that it should actually use classification. So if we do this, this is what we are going to have. So if I should go back again and run this analysis, you are going to see that it's going to come out in a different format. We still have everything there. I'm not changing anything except, so if I run, you see now it's stratified. You can see here now we have DM, male and female for each of the groups. So you can see now the result, you will be able to appreciate the result better compared to when we just go ahead to run it like that. You can see that for those that are diabetic, you can see the values. Yes, although there's no really statistical difference between them, but you can see here for the HB1C, if we go and check the HB1C here, we're going to see that there will be statistical difference in among this that would be DM for HB1C. So let's check DM for HB1C. Okay, although it was not really statistically smooth, but it was actually the one that had the highest, that's the lowest p value in that format. So you can see how we are able to actually stratify to make sure that we are able to get insight into what is actually happening in each of the uh, session. So that is that. So I'm going to stop now and ask if there is question from your end before I continue. Hello?
Hello.
Yeah, can hear you. I can hear you.
I can hear you, sir.
Okay. So I was asking, I've just described the mean, how to actually go ahead and get the, what's it called, to compare the mean in, for t-test. Now this is for t-test. So I'm asking, is there any question that you want to ask? Any question? Okay. So I'm going to continue. I'm going to go back. Then we'll move to ANOVA now. ANOVA simply means analysis of variance. And for you to run analysis of variance, you must have more than two groups. So now for us to do that, I have to go and switch off that selection I did. Then I go to data set, and come here, then I'll say reset. So once I reset it, it will be off. Not select data. There should be split data. I'm going to split data, then tell it to reset. Now click on OK. So now, for you to run ANOVA, you go to Analyze, go to Compare Mean. Then in this case, you come to One-Way ANOVA. So click on One-Way ANOVA. The same way, you can move all this data to you intend to run. Then you can do them one after the other. Then you can do them together. Then you move it here. Then it's age group now that we want to check the factor. But here, under construct, we are not going to change anything. Then under post hoc is usually like the test in between me. Within this age group now, we're trying to check how does one interfere with other. There are a lot of them. But for this now, these ones are actually assuming equal variance is assumed. Equal variance assumed. Why this one is the say equal variance not assumed. So let's actually pick one. Let's pick this LSD, then let's pick any of them. You can actually use any of them. It's not like it's depending on what you are doing. So I pick those two, then I'll continue. Then under Ocean, then I want the descriptive statistics. Then if you want the plot, you can also click on plot. Then if you want homogeneity of variant test, you can click on that, but it's not necessary. You want to continue, then you click on OK. So your result, I wait your result to come out. Then yeah, this is the result. So you can see here, this is these are the plots. Now there's something that just came on. It said also are not performed for FBA because one group has fewer than this. So the reason why post-op was not performed was because of this. I'm going to show you guys now. Now, if you come here, you're going to see that 4 is only 1. So because of that, it will not work. So what I'm going to do now, I'll change one of these to 4. I just manually change that to 4. So let's go back now and run. You know, for you to calculate mean average, it has to be at least 2. You have to have at least 2 to have a mean. So because 4 was just only 1, the software did not calculate anything. So let's go back there now and rerun all those things. Everything remained the same. Then click on OK. So you can see now that it did not give us that error again. It did not give us this error, this initial warning. So this is the output. You can see that total is 20. For age group between 34 to 44, they are 8. 45 to 55, they are 4. 56 to 66, they are 4. 67 to 77, they are 2. 78 to 78 are also 2. So in this case, these are the mean, these are the standard deviation, these are just the descriptive table. Then the next table is the ANOVA table. Now this is your F value. Then these are your P value. So this is showing us the overall ANOVA F result. So this is when you see F value, ANOVA value on tables. This is actually, then this is the P value. This also, this is the P value. And this is the F value, then this is the P value. So in all of this, there's only HB1C that show statistical significance between groups. So within group now is what we want to check. Now for the first one, for the FBA, what this post hoc test do is that it will take one of the age group here to compare between themselves. So you can see here now. Now it compares this and this, and here and you can see that it's not statistically significant. This is 0.075, which is greater than 0.05. Then when you compare the mean value of this age group with this, it was statistically significant. That's why you have this star, and this is the value. You can see this 0.02, 0.03, which is statistically significant. Then when you compare this to this, it was not significant. When you compare this to this, to not significant. Then what it does, it will not take this again, then start comparing among themselves too. So that's what basically how it will do for all of them. So the same thing, a terminal test to also do the same. So that is how what it will actually do. Then for the postprandial too, it does the same thing. Then why for the HbA1c, consider there are more statistically value within themselves here. This compared to this give us this value. Then this compared to this to give us this statistical value. Then this compared to this, there was no. Then this compared to the last one was also statistically significant here. Then we move down. This age group, the HbA1c of this age group compared to this age group gave us this, and we have this statistically significant value. And when you compare to others, they were not statistically significant. But when you compare this age group, the HbA1c of this age group with this age group, which was statistically significant, you can see the mean this value too. Then when this compared to this was statistically significant, then when the HbA1c of this age group compared to this age group was also statistically significant. When this age group too, the HbA1c of this compared to this was not significant, you can see the value. But when the HbA1c of this group compared with this age group, it was also statistically significant. So that's basically how you do your ANOVA. Then these are the mean plots. In case you don't want to write the values out in the table, you can look at this mean plot and see for HbA1c, for fasting blood sugar, this for 2-hour postprandial, then this for HbA1c. So basically, that is how that is done. Then the next thing that we want to quickly look at is when you want to run correlation. Now, if you want to run correlation on any data, for you to run a correlation test, you have to be comparing two continuous data. Now, what I'm saying in essence is for you to run a mean to run correlation, there have to be, you cannot run correlation, for example, between fasting blood sugar and class classification, because these are qualitative data, while these are quantitative data. So you can only run correlation on two continuous variable, two quantitative data sets. So you can check correlation between ABAC and this and this and this. So now we can run for this, then also check age group. Then another thing that we may want to do, we may want to check is to, let's go now that we want to run correlation, go to analyze, then you go to correlate. Now in this case now is bivalent correlation we are doing. You click on bivalent, then you move each of them into the group. So come here. If you need descriptive, you can put it, but if you don't, you can just put it. Then put that, then ask it to is Pearson correlation we are interested in. So then you tell it to flag significant correlation. Then let's look at that. You can see that it will give you the mean values. Now this is the correlation output. Now you can see here now that there is a strong correlation between FBS and 2-hour postprandial. But when you check FBS with HbA1c, there was no the correlation was not significant. Then when you check with H2, it was not significant, because this is the significant value. Then this is the correlation coefficient value. This particular Pearson correlation is also referred to as Pearson correlation coefficient. So this is the p-value, then this is the number. Then the same thing happened here. 2-hour postprandial with fasting blood sugar, it will repeat itself. Then 2-hour postprandial against HbA1c, the same thing. This against these two was not also significant. Then when HbA1c moved with FBS, it will just repeat themselves what we already have here. But the only difference here is that HbA1c with age was positively correlated, because this is positive correlation is 0.05. But if there was minus here, it would be a negative correlation. So that's how we have this correlation. Then when H2 correlated with each of these, we had this particular one. It should just repeat themselves, because we are just repeating the correlation. The HbA1c against age, then age against HbA1c will have the same output. So now the next thing that we may want to do is, now when you may want to check for regression. Let's say you want to check for regression. Now you come here. Let's say you want to do regression. You go to regression. Then you can go to linear regression. And if we want to do linear regression, let's say our dependent variable, let's say in this case is let's say it's HbA1c. Um, okay, let's even say it's age. Then why the independent variable here are these three variables. So remove it here. Then let's say statistics. We want 95% confidence interval. We want the estimate. Then we want descriptive to show. Then that's basically all we need here. Then plot. We want to look at a histogram, but we are not really interested in this. And we want to, okay, let's say normality plot. We want to check that. So let's say now we move. Yeah. Continue. Then save. We want to save membership. Okay, let's say we want to check for adjusted. All these are not really very important to do, but just put them so that we get to know what you are supposed to do. And just, I'm only interested in that adjusted. Then maybe these two. That's okay. Then other option, I'm not including any other thing. So click OK. So have a value here. Is the mean value, is the standard deviation. It will also bring out your correlation. So here we move to the model. Yes, this is actually the most important aspect of this model. This. So what we are saying here is this is actually the uh, this is the um, yes, this is the model. So age is actually what we are. So we are trying to check if age, the impact of age in all of this. So you can see here, this is the odd ratio. Then this is the significant value. And this is actually the uh, lower limit and upper limit. So this will tell you, okay, you can see here, it's not up to 1. So we cannot really, uh, does not really have so much impact. Age does not really have so much impact. But we can see that the beta value is not actually up to 1. So we will not take that. So just check some of these plots, further check if there's anything. So basically that is all. Just do. But normally you don't run regression just like that. All what you always come across to do first is t test and over. So it's only on special request that you run a regression and over as the case may be. So that is it. So I'm going to stop now and take your questions. So I'm set for your questions. Hello.
Yes,
Hello,
sir. I
sir.
have a
Yeah, I can
question.
hear you. Okay. Go on. Go on.
Okay, sir, please. While we were running one examples, I think some you said that error or warning that popped up that
Yes.
something was wrong with the initial, yes, like the red
Yes.
flag that came up. Can
Mm.
you go over it again and explain why and then how and what you did to the data before it was
Yes.
rectified?
Yeah, the data we are uh let me put the data we are using is just what the last student generated. This one. So what they are saying is that post hoc tests are not performed for FBS because at least one group have fewer than two cases. So what it was saying is that if you go back to my data set before I make that amendment, now, sorry, if you go back to the data set before I make this amendment, I was the one that came here to add this second four. Before it was one. So, and if it's one, remember, if you check here now, four is only one. So, because we are dealing with mean values, you can't calculate mean for one case. So it has to be two at least for you to be able to um, calculate, get the average or the mean. So that was what I changed this group to be four. So with that, automatically we have oh sorry.
You get it. You change what group,
Yes,
sir? Just say the name
yeah.
because I'm trying to follow with your screen.
So this is the four. It was one before, so I changed it to four. The reason why I changed it to four was because of the warning that you cannot get results for post hoc because it's just only one group. So that's why if you check here, this part, this group is one. You can see that no mean descriptive statistic was not calculated for them. Can you see it? Can you see it? Eh? Hello? Can you see it? Hello? Hello? I was asking Laura, can you see what I'm trying to show you?
Yes, sir, I can see it.
Okay. So that was why it was not calculated. It wasn't calculated for this. But if you check after I've changed that, you are going to see that it was not calculated for because it's now two. So you can see that the descriptive is completed. So you should always take notes of all those little things that may come up at any point in time. So I'll take more questions if there are. I'm waiting for more questions. So
Hello, good evening.
yeah, good evening, sir.
Uh, my question is based on those dependent value and independent value when we are setting the data. Now, the
Okay.
dependent value, are you the one to choose which value is going to be dependent and which is going to be
Of
independent?
course, you are the one that will define what your dependent and
Okay,
independent
okay.
value is. Yes, based on your
But
research
research work.
questions.
Okay. So my second question now is for like now this data we are using now is like a
Yes,
chemistry data.
yes,
Coding is the coding
yes,
from chemistry data. Now, what about if you have data from medical micro that has to do with
Of course.
sensitivity and growth? Do we
Yes.
just change the value of the out of the results to like 1 and 2 and 3, or we can use it like that in terms of positive and
No,
negative?
for yes, for what is it called? For microbiology analysis, most times they fall under qualitative. Sorry, can you mute? They fall under uh, qualitative data, like the one I showed we did yesterday. Let me use. Let me see if I can pull up that data. Now, something like this. Most times, sensitivity you always is either is sensitive or not sensitive or intermediate. So let's say here and I can be sensitive. I'm using this now as an example. This can be sensitive, not sensitive, then intermediate. So in this case, you will not be running, you're not going to be running t-test. You can't run t-test there. What you'll be checking, if you check most microbiology uh, paper or research papers, what you will always see are chi-square, odd ratios, binary logistic regression like the one I did yesterday. But it's chemistry, hematology, and all of that. Yeah, so part of microbiology, you could also do all those one. For example, when you are dealing with bacterial counts, viral load, dealing with, let's say you are dealing with parasite density. So in those cases, we are dealing with numbers. So you can go ahead. But another thing too, if you are looking at MIC, for example, if you are doing MIC, if your organization or your research is MIC, MIC are usually reported in numbers too. So you could also uh, use ANOVA, use t-test and all of that. But basically for microbiology kind of results, most times always fall under qualitative data set. And this guy is not even here and he has left. So any more questions? Because tomorrow we are ending the class, then we are going to be dealing with non-parametric test.
All right. This one is not really a question. It's like a request.
Okay. Go on.
Please, is it possible for me to get a copy of the data you're using so I can use it to practice?
Of course, I'll make it available.
I would like to have you. You can drop it in the group because most of these things I'm just learning, but I'll not be able to put it in practice, so I can.
I will make the data available for you.
All right. Thank you very much.
Any question? More questions?
Sorry. Sorry. One more thing. The same thing that applies to data from medical micro. It can also apply to data from histopathology.
Most often, yes. Most often.
Okay. So in those cases, we cannot be doing ANOVA or t-test or anything. We'll be doing the other types of statistical analysis.
chi-square, odd ratio, risk, relative risks, and logistic regression and the case of.
All right. Thank you.
More questions? Hello? More questions? So if there's no questions, I'll still make this record available, probably now or later today. Then tomorrow we'll be having the conclusion of the class. I'll be looking at non-parametric test. So if there's any other question after tomorrow, then you can bring it up to the group. for discussion. So I'm going to make the data set available so that you can practice with it. Basically, yes.
Okay. All right.
So
Thank
if
you
there is
very
no
much.
more, if there's no more questions,
Even though the network is quite frustrating.
so sorry about that. You enjoy the recording aspect because my whole internet is actually good. There's no teaching, so you'll be able to enjoy the recording because the breakage will not be there. So I want to appreciate all of you, and I see you guys tomorrow for the conclusion of the class. Thank you.
All right.
God bless you.
Thank you. Good night.
Thank you. Good night.
Good night.